Sequences and proof. Hello there. Right, I'm going to try to keep this video under 5 minutes. Right, first we're going to look at what are called linear sequences. They look like this. You have some terms, and the 3 dots indicate that the sequence continues. We're going to find the rule. Here's what you do. Draw a loop between each of the terms and calculate the difference. It should be the same for a linear one. In this case it's +3. Then work backwards. What would be 4, 5? The answer would be +2. Notice how I put the sign in. Now, to find the rule, here's what you do. Now we use the symbols U, capital U, and N for the nth term, equals +3 times N, and then +2. And that's the general rule, the nth term. Look at one more, and then we'll look at quadratic sequences. Right, draw a loop, as I said, between each term. This time we're subtracting 4, so that's the difference. Sorry about that. If we work backwards, what would be the one before 8? It would be +12. So the nth term, the general rule, is -4n +12. Okay, now, what about quadratic sequences? Well, let's look at one of these. 4, 7, 12, 19. Right, first we find the difference between each term. And what we notice is that should be +3, that's +5, that's +7, is that they're not the same. So we find what's called the second difference. That's the difference between differences, and it's +2. Darn. Computer, be slower than my handwriting. So it's +2. So what would be? So we notice that the second difference is +2, which means that our rule is n squared. Oh, do you know, 1 microsecond slower and everything would be okay. Now, how do we work out the term before the first? Well, we have to here work out the first difference. Now, we know by the fact that the second differences are +2 that this one must be +1, so the term before 4 must be +3. So the rule is +3. Okay, now, how do we use these? Here's a typical question. Question A. Find the 10th term of the sequence. That's bad handwriting, isn't it? Given by un equals 5n -2. So we're going to find the 10th term. So we substitute that. We substitute the value 10 into this expression here, replacing n. So the 10th term, sorry, I prefer red, the 10th term equals 5 times 10, take away 2. From bid maths, we do the multiplying first. 50 take away 2 equal to 48. Now, here's a question that's been cropping up recently. Is 78 a term in the sequence given by? Now, how do we do it? Well, we'll think of values or some numbers that will give us, when we put them into this expression, a number close to 78. So let's try n equal to 9. So u9 equals 8 times 9 plus 5 equal to 72 plus 5 equal to 77. What about the term after that? What about the 10th term? Well, the 10th term is 8 times 10. What's been inconsistent here? Apologies. Plus 5 to give 80 plus 5 equal to 85. And then we write a brief line to say 78 is not a term in the sequence. How have we shown it? Well, we've shown that the closest term below 78 is 77, which is not 78, and we've shown that the next term is 85, and there's nothing in between 77 and 85, hence it cannot be a term in the sequence. Okay, thank you for listening.